Use elimination method to find a general solution of the given system where differentiation is with respect to t. So what that means is that this x prime means dx by dt, and this y prime means dy by dt. So they're telling us to eliminate x and solve for y. So in this case, it's relatively easy to eliminate the x because from the second equation, you can see that x prime is equal to y prime, and then you substitute here, and that would eliminate the x. So let's just rewrite these equations. So x prime plus 2y is equal to 0. X prime plus 2y is equal to 0. And then the second one was x prime minus y prime is equal to 0. So the second one implies that x prime is equal to y prime. And we substitute this in this first one. So replace the x prime with y prime. So you have y prime plus 2y is equal to 0. And this can be done by separation. So y prime is equal to negative 2y. So remember, y prime was dy by dt. So dy by dt is equal to negative 2y. And then in separation of variables, you would do dy over y is equal to negative 2 dt. And so when you integrate both sides, this is ln y is equal to negative 2t plus c. And y would be e power negative 2t plus c. So if you look at the answers, you do not have any answer of this form where the c is added onto the exponential. So one way to simplify this is you break it up, e to the negative 2t times e to the c. And now e to the c is another constant, and they are calling, if you look at their choices, you can call it anything, any constant letter, but they are calling it c2. c2 e to the negative 2t. So if we go back to the problem, c2 e to the negative 2t. Okay, and then in the second part, you have to find x. So now we already have x prime is equal to y prime. So we have x prime is equal to y prime. And when the derivatives of two functions are equal, one of them is a constant plus the other. So you find x will be y plus a constant, and they are calling that constant as c1. So y is c2 e to the negative 2t plus c1. C to the e negative 2t plus c1 e power negative 2t plus c1. Now, I was earlier trying, instead of c1, I was trying to write just a, because a is also a constant, but for some reason it wasn't accepting the answer. So if it happens that you have everything right, and it's just that you have used a different letter for a constant than what they have now, this constant and this constant have to be different. So as long as you're using two different things for this constant and this constant, and everything else is the same, and if this happens in an exam and it marks it wrong, you can always show me and I can give you back the points. Now, here it looks very similar to problem 1, but there is a major difference, because remember, in problem 1, you just found x prime is equal to y prime, and when you substituted it here, the x's got eliminated and you just got an equation in terms of y's. Here, if you look at it, I mean, there doesn't seem to be a simple way of substituting something from one equation to the other and eliminate one of the variables. So the general method in these problems is to use a differential operator. So let's rewrite the problem. X prime is equal to x minus y, and y prime is equal to y minus 9x. X prime is equal to x minus y, and y prime is equal to y, was it minus 9x? Y minus 9x. So in this case, since the derivatives are with respect to t, so what you do is you let d is equal to d over dt. So we use this symbol. And then since this is dx over dt, so this becomes dx, and this is equal to x minus y. And the second equation becomes, this will be d of y is equal to y minus 9x. And the goal is to eliminate x. So to eliminate x, what we can do is, so let's call this as 1 and this as 2. So from 1, or we can do from 2, we can calculate what x is. So you have d minus 1. So you have d minus dy minus y is equal to negative 9x. Or you have d minus 1 y is equal to negative 9x. And now if we divide by negative 9, we get x is equal to negative d, and then, okay, d, negative d plus 1 over 9 y. Okay, so we substitute this in the other equation. So we substitute this in 1. X is equal to negative d plus 1 over 9 whole times y. So equation 1 becomes dx is equal to x minus y. So d x is negative d plus 1 y over 9. Dx is equal to x minus y. So x is again negative d plus 1 over 9 y. minus y. So to clear the fraction, we can multiply everything with 9. So this becomes negative d squared plus d y is equal to negative d plus 1 y minus y, minus 9y, because everything is being multiplied by 9. And now we collect everything on the left side. So you'll have negative d squared plus d minus 1 plus 9. Y is equal to 0. And this becomes negative d squared plus 2d plus 8. And to get the leading term positive, we multiply everything with negative 1. So we'll have d squared minus 2d minus 8. D squared minus 2d minus 8. Y is equal to 0. Now remember, d was dy by dt. D was d by dt. So basically, this is the second derivative of y. So when you open it up, this is d squared y. So this is actually y double prime minus 2y prime, because d was d by dt. So this is like d by dt of y. So that's y prime minus 8y. Now, this is a linear homogeneous second order equation. We know how to do it. Auxiliary, we write the auxiliary equation. Br squared minus 2r minus 8 is equal to 0. So r minus 4, r plus 2. So r is equal to 4 and negative 2. And the general solution is y is equal to c1 e to the 4t plus c2 e to the minus 2t. c1 e4t plus c2 e to the minus 2t. So this is the same thing, e to the 4t and e to the minus 2t, they have the constant switched around, so it doesn't matter which constant you put with which one. Okay, and I have to solve for x, and you can use this equation or you can use this equation. In fact, we already had solved for x from this equation. So if you remember, we can just rewrite it as 9x is equal to y minus y prime. So if you solve this, you get, if you bring the 9x on the left side, you get y minus y prime for the 9x and divided by 9. That will give you the x is equal to y minus y prime y minus y prime. Okay. So let's say okay. So let's think this is y prime, but we do have y prime. We have y in this one, And so maybe it'd be simpler if I just go back to Word. So x is equal to y minus 1 over 9 y minus y prime. X is equal to 1 over 9 y minus y prime. Go back to this. So you have it here also, 1 over 9, and this is y minus y prime. Okay. We could even write it exactly in this form, negative y prime plus y. So I'm just writing it in that form, negative y prime plus y over 9. So y prime can be calculated. So y prime is the derivative of this y. So the derivative of this is 4c1e40 minus 2c2 e to the negative 2t. And now remember, they had their C1s and C2 backwards. So they had C2 here and they had C1 here for the Y. So let's just keep that. So 4C2 e to the 4t minus 2C1 e to the negative 2t. And then plus Y. So plus Y means just plus C2 e to the 4t plus C1 e to the negative 2t. Now simplify. So 1 over 9 and 4c2e40 plus c2e40 would be 5c2 e to the 40 and minus 2c1 plus c1. So it'll be minus c1 e to the negative 2t. Okay, so that's for the y. So I can split it up. So 5 over 9 c2 e to the 40 5 over 9 c2 e to the 40. And what was the other one? Minus 1 over 9. C1 e to the negative 2t. Okay, 5 over 9 C2 E40. Let's go back. C1 E minus 2t plus C2 E40. C1E minus 2t plus C2 E40. Okay, 1 over 9 negative y prime plus y. Oh, this was a negative y prime. So, and this was just, these first two terms are just y prime. We took the derivative and we forgot about this negative. So this is a negative and this would be a positive. So now the simplification would be negative 4c2 plus c2 would be negative 3c2. And 2c1 plus c1 would be plus 3c1. And this one can even be simplified further, plus 3c1. So this is negative 3 and this is 3, and so cancel with the 9. So this one being negative 1 over 3 c2 e to the 40 and then plus 1 over 3 c1 e to the negative 2t. So negative 1 over 3 C2 and 1 over 3 C1. Negative 1 over 3 C2 and plus 1 over 3 C1. Negative 1 over 3 C2 plus 1 over 3 C1. Okay.